Client applications that consume language models enable users to leverage powerful natural language processing, NLP, capabilities directly in their applications. Azure AI provides extensive tools and cognitive services to implement these advanced linguistic functionalities. Integrating language models facilitates diverse NLP tasks, including entity extraction, summarization, sentiment analysis, and language detection. With Azure, applications can tap into robust pre-built models or customize existing models to fit specific requirements, providing enhanced user experiences through intelligent language processing and interactive conversational interfaces. Azure Language Services provide cloud-based NLP capabilities, enabling developers to integrate sophisticated language processing features into their apps. Core functionalities include sentiment analysis, key phrase extraction, language detection, named entity recognition, NER, personal identifiable information, PII, detection. Azure facilitates consumption of these services through RESTful APIs and SDKs available for popular programming languages, providing straightforward and secure methods to seamlessly deploy NLP capabilities into a variety of client application types, ensuring accessibility, scalability, and maintainability. Consuming Azure language models can be approached by using REST API, direct HTTP requests integrating NLP functionalities, Azure SDKs, simplified and idiomatic integrations in various languages such as JavaScript, Python, .NET, and Java, integration with Azure Functions, serverless execution for event-driven language processing scripts. These approaches cater to different development preferences, whether emphasizing flexibility and control, REST APIs, or ease of use, abstraction, and faster development cycles, SDKs, empowering developers to choose optimal consumption methods tailored to their specific application scenarios. Consuming Azure language models requires these steps. Create an Azure account. Provision language service resource in Azure Portal. Go to portal.azure.com, search language service, fill in resource group, region, and pricing tier options. Click Create to finish provisioning. Retrieve key and endpoint from created resource for authentication. These steps set the stage to securely and effectively integrate language processing capabilities within your targeted client application, providing essential access and usage management via Azure Security Frameworks. REST APIs provide flexible interaction with Azure Language Services, HTTP-based communication, enabling interaction from any programming language that supports HTTP requests. Uses standardized JSON responses, easily parsed and integrated. HTTP request example. HTTP post HTTPS / endpoint /text /analytics /v3.2 sentiment header. OCPM subscription key. Key documents, language, and a D1, text, hello world. REST APIs are optimal for granular control over requests, response management, and platform-independent application development. Azure SDKs greatly simplify the integration and consumption of language models, designed specifically for optimal Azure use. Supports many popular programming languages. Provides well-defined classes and methods tailored towards Azure Language Processing APIs. Example in Python. Python from Azure.ai. Text Analytics import Text Analytics client from Azure.core. Credentials import Azure Key Credential Client equals Text Analytics Client. Endpoint equals endpoint. Credential equals Azure Key Credential. Key. Response equals client that analyze _ sentiment. Azure SDK simplifies NLP. This straightforward implementation reflects the ease and clarity offered by the Azure SDK. Client applications interacting with Azure NLP services require proper authentication. Azure provides secure authentication options, subscription keys, simple implementation, included in request headers. Azure Active Directory, AAD, enhanced identity and access management, and greater security. Subscription key method example. HTTP header. OCPM subscription key. Eurocity OAuth tokens secure complex enterprise-grade implementations efficiently, offering granular access control aligned with best security practices. Consuming Azure NLP services requires attention to data protection, applies encryption in transit via HTTPS. Compliance. Azure services provide compliance with international, regional, and industrial standards like GDPR, HIPAA. Role-based access control, RBAC, to assign precise user permissions and operations within the Azure portal. Developing applications considerate of these security and compliance aspects ensures responsible data handling, preventing unauthorized access while conforming to important regulatory guidelines and maintaining user trust. Performance optimization is essential. Minimize latency by selecting Azure service regions geographically close to your users. Optimize requests by batch submission of texts whenever applicable. Implement robust caching strategies. Cache frequently used information. Regular monitoring and Azure Application Insights integration to identify performance bottlenecks. Such strategies maintain high-performance standards in client apps, reinforcing seamless interaction experiences and responsive NLP operations for end users. To build robust NLP applications, implement error handling to anticipate and manage exceptions effectively, such as HTTP connection errors, API request limit exceeded, incorrect input formatting, log failures, and API response anomalies utilizing structured logging practices. Apply retry policies to manage transient service disruptions gracefully with exponential backoffs. These practices sustain reliability and fault tolerance in client applications when interacting with Azure AI services. Azure provides solutions to scale NLP client applications efficiently. Auto-scaling services, Azure App Service and Azure Kubernetes Services, AKS, allow automatic resource adjustment to accommodate demand. Azure Functions, scalable serverless solutions, provisioning resources dynamically based on load. Load balancing and redundancy, distributing application traffic to ensure responsive service under high load. Implementing these mechanisms ensures stable, scalable, and cost-effective operations under variable usage scenarios. Best practices when consuming NLP services: clearly structure and pre-process input texts. Batch API interaction for efficiency. Comprehensive and regular application monitoring and error logging. Continuously test and validate application responses against realistic datasets. Manage API key and secrets securely. Adhering to these practices supports resilient and efficient NLP integration in client apps, promoting a reliable end-user experience and ease of application maintenance.